So welcome to week 0 of Space Science with Spice. The purpose of this video is just an introduction to what this club is all about, so I'll try to keep it quick. As always, timestamps for each of the 4 parts are in the description if you want to skip around. And if you don't know me, hi, I'm Zain. I tutor most subjects at the middle and high school level, so reach out if you need help with anything. So let's start with part 1. Why are we learning how to code if this is a physics-based club? So when most people think of science and engineering, they imagine someone wearing a white coat and working in a lab. And while experiments are certainly like a key, huge part of the scientific and design process, most scientists and engineers today also spend a ton of time writing computer code. And here's why. If you think about how much time you'd save on your homework when you use a calculator to do math operations, just imagine how much time you can save teaching a computer how to perform those calculations on its own. Not to mention how many more possibilities open up for simulating complex phenomena. And that's why it's really important for you to learn how to code when you're learning physics, or really any field of science and math, and even a lot of pure math and engineering, sorry. And in this club, I'm going to provide you with the videos and activities to help you learn coding in a physics, science, and engineering context. You don't need any experience at all, and at least right now, you won't have to install any complicated software. All you need is a computer with internet connection, so if you're watching this right now, you qualify. Part 2 is just going to give you a taste of the projects we're going to be working on over the year. So we'll be working mainly with a beginner-friendly language called Python. We'll be taking our understanding of the force of gravity and start by translating that into a code function while using some common techniques in computational physics to optimize it. And then, using a library called VPython, which you're looking at right now, we can make a small solar system with a bunch of different bodies before we move into stuff like binary star systems. But just starting with this example, if you wait a bit, you'll see a comet that's going to loop around the sun. Except for it is painfully slow. That's pretty cool, you could rotate it around. And if you're curious to why that tail is going outwards, it's actually going away from the sun at all times. So yeah, as this comet takes its sweet time circling around, if you zoom in even closer, whoop, there it goes. Sorry, I got distracted. If you zoom in even closer, you might notice that the sun is actually moving around. Look at that trail, or that path being traced right there. That's scary to me. That's a conspiracy. It's amazing, but it's also completely unexpected. And it just begs the question, does the actual sun, the one up there, do that too? And so to investigate that question about the sun, we're going to be using this library called SPICE, which NASA itself right now uses to plan space missions and analyze the data they collect from spacecraft like Voyager and Cassini. So to start, we're going to use SPICE to make an accurate simulation of our own solar system with all the planets we know and love. And then we're going to do some data analysis to analyze whether or not the sun actually moves, and more importantly, why or why not. And I won't spoil too much for you, but the answer lies somewhere in those graphs at the bottom right. After that, I'm not sure exactly what we're going to be working on. It's more up to you guys, but the potential projects I have in mind are... So on the basic physics route, using our gravity function, we can make a black hole simulator that demonstrates this phenomenon called spaghettification, which basically means that if you were to fall into a black hole, it actually stretch you apart from your head up here to your toes down here, like you're a piece of spaghetti. And unrelated, quick tangent, surprisingly this wouldn't actually hurt because the electrons transmitting the pain signals from your nerves wouldn't be fast enough to escape the gravitational pull and make it to your brain, so you die a painless death, but it might be a bit scary. There is also this cool little 3D pendulum that's surprisingly difficult to make. First we're going to do it without, then we're going to do it with relativistic effects. And then we can go into more advanced physics and do some work with electromagnetism or quantum mechanics if we get to that point. We can also go the more computer science and data analysis heavy route and continue to use SPICE to do stuff like analyze the PNC type comets around Jupiter, calculate the best times to go outside and look for planets lined up in the sky and take photos, or take a crack at discovering some exoplanets. Either way, it's really just what you guys want. So part 3 is more about the expectations and objectives and what I really want this club to be. So, on a more broad note, as we discuss the phenomena within physics, I really hope you guys get the sense that there are questions lurking within the models we're making, like the sun moving, hiding in plain sight. Intuitively, it'll feel like there's some connection and patterns we can uncover, but at the same time, the meaning isn't completely clear. It's a real mystery, and so hopefully the questions we're addressing feel authentic and compelling. And like so many authentic mysteries in physics and math and computer science, there's an answer that's both beautiful and profoundly satisfying. And of course, I'm not going to tell you what it is. That's because I know that if I rushed an answer, I would have robbed you of the opportunity to learn. Actual learning only happens when we have time to struggle through a problem. And so, although I'll be giving you guys quote unquote homework, insofar as I truly believe that the only way for you to truly understand something is to discover it yourself, I'm going to do my best to stay away from memorization or tests or grades because we don't have a curriculum or an exam to study for. I'm not trying to fail you guys. My goal is to have you experience the beauty of computational physics in a creative, engaging, and most importantly, fun way. This also means that if you have any suggestions for feedback and you communicate that to me, I'll try my best to change it. I really am doing this for you guys' sake. On prerequisites for the course, I'm assuming everyone is starting as a beginner in physics and computer science. No prior knowledge is needed aside from a bit of basic algebra, and I'm willing to work individually with people who need extra help or want to explore things further. For those of you who are already ahead, I'm going to make sure that you're not forced to sit through work that's too easy for you as well. Um, Oops. On the specifics of how I'm going to be running the club in terms of lectures and meetings, we're going to be going through a bi-weekly schedule where on the week where we don't have a meeting, I'm going to post a pre-recorded video lecture on YouTube like this one for you to watch on your own time, along with an open-ended problem. And for the week after that, I'm going to hold a Zoom that'll serve almost like office hours, where you can come in and ask questions, check over your work, or just talk about space-related news. Although if you're busy on Fridays, I'd be happy to work with you individually as well. I chose this model for like three interconnected reasons. First, it'll help accommodate people coming from different physics or coding backgrounds, since you can pause at the parts that confuse you, or speed through and skip over parts you already know. Hopefully this learning experience is more flexible and engaging for you guys' schedules, although it will take some responsibility and self-discipline, since you're going to have to do some stuff on your own. And second, you can't really use the excuse that you can't join the club because you're busy on Friday, since attendance isn't mandatory. This club is asynchronous. If you have 1 or 2 hours of free time every week, you can participate. And the third reason is similarly, if you miss a meeting or you're joining us late, hi, you don't have to drop the club, you can still catch up at your own pace. And just to be clear, if you or a friend are still unsure of whether or not you want to join the you don't have to leave the classroom or the Discord. You can just passively look or comment on what we're doing, and if you ever want to jump in, you're welcome to start watching the videos. And finally, hopefully by the end of the year, you can also build up a pretty cool portfolio of coding projects that you can show off to colleges or summer program applications, which, by the way, on the summer program applications, the Math Honor Society is mentoring applications, so look on Classroom or Discord for a flyer. And if you guys want, I can teach you how to upload your projects to GitHub, which makes it look a bit more professional. Now, part 4. This is platforms for people who are really interested in joining. We have 3 main platforms. The first one, all Fairlawn High School students should be in our Google Classroom. The code is FKXSMMY. All of these shouldn't take, just do this right now. It's not going to take that long. Here's another quick Google form, and this shouldn't take more than 2 minutes. All of the links will be in the description for you guys to fill out. Ideally, pause the video right now and go fill it out. You don't worry about saying that you don't have any experience in these fields, because I'm not going to look at the names associated with the responses. It's more so I can move at a pace that's right for you guys, but in a way that's still pretty engaging to you. And we also have a Discord that I highly recommend you join. And if you're not from Fairlawn High School, this is where you're going to get your access to everything that's posted on Google Classroom. The invite link is going to be posted in the description, and I've also included 2 Discord guides. One is quick and one is a little more thorough. This is your first time using Discord, and make sure that as soon as you join the Discord, you will private message me, Zain Kamal or Humble Penguin, so I can give you the student role that lets you access the rest of the server and chat with everyone else. So, oh, I forgot to take the sign out. Yeah, that's the end of it. If you have any questions, feel free to email me, feel free to message me, or just make a post on Classroom. And I look forward to working with you guys for the rest of the year. Take care and see you next week, guys.